We have already discussed internet protocol is related to network layer. Now we are discussing about IP addressing. In the network layer, mainly we concentrate on taking the segment information and making it into packets. At the receiving end, we want to convert these packets again into segments. This is the primary task, and the secondary task is to assign the addresses. That's what we call as internet protocol addresses. And the third task is routing these packets with this address. Now we are discussing about this second aspect of the network layer, that is IP addressing, internet protocol addressing. Whenever we want to connect to the internet, when a device wants to connect to the internet, definitely it should have a IP address, internet protocol address. So the billion of devices in this internet protocol addressing, when they are connected to the internet, each device has its own unique address which differs from the other device. So when we are connecting to the internet, if 100 devices are connected, each device, when we are connecting to the internet, if each device is using different network, remember my point, if each device is using different network, then for those each different networks we have different IP address. Now here we see there are two versions of the IP internet protocol addresses. Generally we now observe even in our computer also when we set up the IP address. This may be IPv4 or IPv6, Internet Protocol version 4 or Internet Protocol version 6. So IPv4 is a 32-bit address and IPv6 is a 128-bit address. With the IPv4, we can give 2 to the power 32 addresses because it is a 32-bit address. We look these 32-bit addresses, we look these 32 bits as 4 bytes. This is how byte 1, byte 2, byte 3, byte 4. And similarly, in IPv6, we have 128 bits. Later we will discuss about the IPv6. Now we are discussing about IPv4. Now, we already discussed each address gives the ability to connect the device to the internet. Without that address, we cannot connect to the internet. If your device is connecting to the internet, definitely your device has your IP address. Whether you know or do not know, that is secondary. But if you are connecting to the internet, sir, I am connecting with mobile. Does my mobile have IP address? Yes. I am connecting with some other device which is not mobile and computer, but it is accessing internet. Does it have IP address? Yes, if it is accessing to the internet. So whatever the device is connecting to the internet, definitely it has an IP address. Mainly these addresses are divided into two types. IPv4 now we are discussing. One is classful addressing, second one is classless addressing. So format of the address is, we will take the network ID and the second one is the host ID. These two parts will be there, network ID and host ID. In some of the classes, network ID bits may be 18 or 16 or 24. In class A, network ID bits are 8. In class B, network ID bits are 16. In class C, network ID bits are 24. we are using classes. That's why it is called as class full addressing, because you are using classes for the addressing. The concept of classes are introduced in the class full addressing. We are using 5 classes in the address space: class A, class B, class C, class D, class E. And for the addressing of these 5 classes, we are using 2 notations. One is binary notation like this, 1 0 0 0, this one 4 bytes. But this is not much popular because it is difficult for us to read. We have to calculate. But it is very easy in the decimal notation. 128, it does not mean that whatever the binary notation we are representing here, this is different from here. Only it is a representation. India you may represent in English, or India you may represent in Telugu, or India you may represent in Hindi. Whatever may be the language, whatever you are representing, finally all these are representing the same India. Similarly, whether you represent with these bits or whether you represent in decimal format, you are representing the same address. This is only notation. So here we are discussing who gave this, whatever we have discussed in addressing format, who are giving these addresses. For each region, one organization is there. For the Asia Pacific region, there is an organization called Asia Pacific Information Center, APNIC. It will give the IP address for you. Now in the class A, we have 4 bytes, you see. Byte 1, byte 2, byte 3, byte 4. In class A, byte 1, it starts with 0 and ends with 127. Class B, byte 1, starts with 128 and ends with 191. And class C, 192 to 223. And class D, 224 to 239. And class E, 240 to 255. Class A, B, C we use for the commercial purpose. Class D we use for the multicasting purpose. Simultaneously, when we want to address a group of hosts, at that time we use this multicasting. For the research and development purpose, we use the class E. In this class D and E, there is a much wastage of addresses are there. This is the disadvantage of class full addressing. Wastage of addresses. Now the class A address, byte 1 starts with 0. You take whatever may be 0 to 127, it will starts with 0. Starting with 0, remaining. 127, 0 all ones. 0, 1, 1, 1, 1, 1, 1, 1, 1, 1. 7 ones, 3, 3, okay. And similarly, class B byte 1 addresses, they start with 10. And class C byte 1 addresses, they start with 110. Class D byte 1 addresses, they will start with 1110. Class E byte 1 addresses, they will start with the 4 ones. Now here you check in byte 1, byte 2, byte 3, byte 4, class A we have only one byte for the network address. Network ID I can say. So only one byte for the network ID. This is the format of the address, network ID, host ID. In class B, we have 2 bytes for the network ID. In class C, we have 3 bytes for the network ID. So in class 1, we have 3 bytes for the host ID. In class B, we have 2 bytes for the host ID. In class C, we have 1 byte for the host ID. Whenever we are using the mask, at that time we are making all the network ID bits to 1 and all the host ID bits to 0. So here if I am making class A, whenever we are using that mask, 255.0.0.0, 255.255.0.0, 255.255.255.0 when we are masking. Next we are discussing the parts of the IP addresses. Here we have class, whether a class A, class B, class C, class D, class E. And we have the network number and the host number. What is the network number and what is the host number? Class A we use for the large organization hosts. We will discuss with the statistics also. For the large organization, in an organization, in a network, when a particular organization is having more number of employees, more number of devices, more number of communicating devices, at that time we go for the class A, because in class A number of networks are small. How many number of networks? 128. But number of addresses are more. 256 into 256 into 256. So large organization with the number of networks might be small, but in each network we have a large connectivity of the addresses. For the large organization we use class A. For the mid-size organization we use for the class B. For the small organization we use class C, where our requirement we can address at that time 256, but our networks are 223 minus 192 means 32 into 256 into 256. 32 into 256 into 256. That many networks we have. But our hosts are only 256. When we have small number of devices, but the networks we have more networks, then that's for small organizations we go for the class C. Here we are discussing about, now you see, now we will be discussing, we already discussed multicasting, and E generally we use for the research, future use. Generally we use this as a R&D for research and development. These are reserved for research and development. That's why in D and E there is a much wastage of address fields are observed. So we are once again, we will continue from this part, but once again just we are revising. We discussed IP addressing. Address is must for a device to connect to the internet. In this IP addressing we have two versions, IPv4 and IPv6. IPv4 is a 32-bit address, IPv6 is a 128-bit address. In IPv4 we have classifying the addresses based on classes, two types, class full addressing and classless addressing. Format of the class full addressing is network ID and host ID. In class full, network ID may be 8 bits or 16 bits or 24 bits. And we discussed the classes are A, B. How many classes we have in class full addressing? 5 classes. Class A, B, C, D, E. We can denote the addresses either in binary format or decimal format. So who gave this class A, B, C, D, E, the addresses who are giving? There is an organization for our region, Asia Pacific Information Center, that is giving. Class A first byte addresses are from 0 to 127. Now you tell if the first byte address is some 58, which class it is? Class A, because 58 is in 0 to. If the first byte address is 150, then it is class B. If the first byte is 201, class C. If the first byte is 226, If the first byte is 255, class E. Okay. Generally, it is starting with 0, 1, 0, 1, 1, 0, 1, 1, 1, 1, 0, all ones we have discussed. If we mask the bits, then masking will happen when we make all network ID bits as 1 and host bits as 0. At the time, how the addresses will be also we discussed. Now we will discuss some other fields. The leading bits of class A we have already discussed 0. The leading bits of class B 10, class C 110, class D 1110, class E 4 ones. Size of the network field in class A 8 bits, in class B 16 bits, in class C 24 bits. So the number of networks in class A are 128, in class B are 191 minus 128. 128 to 191 means 64 networks. 64 networks into 256, because second bit is also network bit. So 64 into 256, 16,384 networks we can establish by using class B connection, class B address. So class C 192 to 223 means 32 into 256 into 256. We can establish 20,97,152 networks by using class C. Class D, class E, anyway, we are not interested for the commercial purpose. We are not defining it. Network field and host bit we are not defining, because we don't want to communicate with a particular host. We want to communicate with a group of hosts. Similarly, the address per network in class A 256 into 256 into 256. 256 into 256 into 256. So it is 16 lakhs or 1 crore 67 lakhs 77,216 addresses per each network we can address. In class B 256 into 256, 65,336 addresses we can address per each network. In class C 256 addresses we can address per each network. So the total number of addresses with class A, we are taking 128 into 256 into 256 into 256. It is nothing but 1, 10, 100, 1,000, 10,000, 1 lakh, 10 lakh, 1 crore, 10 crore, 100 crores. 214 crores almost. 214 crores addresses we can address by using class A. And 107 crores addresses we can address by using class B. 53 lakhs addresses we can address by using class C. By using class D we can address 26 lakhs addresses. 1, 10, 100, 1,000, 10,000, 1 lakh, 10 lakh, crore. 26 crores. 26 crores addresses we can address by using class D. And similarly 26 crores. How 26 crore came? Because here this is 16 into remaining 3 bits are 256 into 256 into 256. We can observe a huge number of 26 crores of addresses we are wasting with class D and E. This is the disadvantage with the classful addressing. We are not using this for the commercial usage. Starting address of class A 0.0.0.0, class B 128.0.0.0, class C 192.0.0.0, Class D 224.0.0.0. Class E 240.0.0.0. Ending address 127.255.255.255. Class B 191.255.255.255. Class C 223.255.255. Another 255. Class D 239.255.255.255. Class E 255.255.255.255. Now we are discussing about the subnet mask. If we mask the network bit 1 and host bits 0, then we discussed already. For class A it is 255.0.0.0. For class B it is 255.255.0.0. Class C it is 255.255.255.0. For D and E not defined. This is how we will address by using the classful address of the IP version 4.